Hi everyone, my name is Ben Walker. I'm a distance learning student, and I chose the Memento pattern to discuss with you today. So a quick overview is the point of this one is to store information of any type as a backup. And then that data can be changed, and if the user decides they want to undo that change and restore to the original data, they can then access that stored memento and load from it. There are three parts of this. There is an originator, a caretaker, and a memento. And the originator will write to the memento, and that memento will be stored in the caretaker. And then when the originator wants that stored data back, it will pull the memento back into the data. So I found this intent statement online, and I thought it summed it up pretty well. So we don't want to violate encapsulation. We only want the originator to know what's inside of the memento. And we want to externalize the originator's internal state so that it can be restored later. The stored data can be used again later is the point. The motivation for this? Being able to undo something or restore something after a crash is absolutely important. Checkpoints, very important to not lose data. I can't imagine the last thing I've done without hitting an undo button. This is to avoid countering what was actually done, and that's covered in the last slide of purposes of this and actual uses. So the main structure contains the three parts I mentioned earlier, the originator, the memento, and the caretaker. And the originator creates the data and decides if it wants to load data back in that was stored, or create new saved data, or just work with the data it has. The memento listens to the originator and will get information from it or set itself to the stored data so the originator can access it. The caretaker is solely there for encapsulation to make sure the data isn't viewed from the outside and as a storage container. So I found 5 major consequences to using the memento pattern. Preserving encapsulation boundaries is a plus because it avoids exposing information and keeps that information just known to the originator. Nothing can know it from the outside. It's stored in the caretaker and is only dealt with by the originator. It can simplify the originator. Normally an originator could have all of this data stored within itself, but by storing the data in a memento and keeping it separate but contained at the same time, it allows the originator to deal with just the data at hand and then decide later to access something stored somewhere else instead of dealing with data at hand and storing the data. A possible negative is using the mementos could be expensive. If many mementos are created, or if they're being pulled in over and over, meaning many undos or many restores, this could be a high cost because unless the restoring is a cheap cost, which can happen, but isn't always guaranteed. Defining narrow and wide interfaces. So this pattern can be hard in some languages to ensure encapsulation. We only want the originator to know what is the memento state, and in some programming languages this could be easier or more difficult depending on the ability of the language. There are also many potential hidden costs because the caretaker can't know anything about the memento. And if it doesn't know anything about the memento and it's storing many of them and they hold massive amounts of data, this can lead to problems because the caretaker may not be prepared to hold that much data. So I wrote out one known use. I'm sure you guys can think of many different ways this could be used, but the one example I found is if, say, you take a shape or a text or something and you shift it to the right. Now, you stored the original position of that shape so you could use it later in case you wanted to undo any changes you might make. So to undo a movement to the right, you would think you would move the object to the left by the same amount you moved it to the right. This method would allow you, the memento pattern that is, would allow you to access the original state and just set the shape back to its original location instead of countering the rightwards movement with an equal leftwards movement. I'm going to try to change my recording software to another screen now. This is the code I created for the memento pattern. I made 3 structs, an object, a memento, and a caretaker storage, all with the same fields, just name, age, and info. These were just 3 generic things I decided to pick, and they all have the same 3 things in them. This is so I can change an object into a memento and a memento into caretaker storage. This function here takes an object and changes it into a memento for storage. An object will contain the raw data input in the originator. The memento load is the reverse of this. It will take something from caretaker storage and turn it back into a memento. So I guess I should have stated the overall flow is you take raw data into an object, that object is turned into a memento, and that memento is turned into caretaker storage. And then to get that from the storage, you take caretaker storage, turn it back into a memento back into an object, and the object back into raw data. Here's my originator. This is what takes the raw data in, 2 strings and an int, and turns it into an object. That then would be passed up here to the save, and that save would pass it into our caretaker. The originator load does the opposite again. It takes a memento and turns it back into an object, which is then shown as raw data. The caretaker only has one way, and that is memento to caretaker storage. This will store our memento in a file type or a variable type, the caretaker storage struct, that no other thing knows how to view except for the memento. Only the memento can access a caretaker storage type. So here is a variable of each type. I go through and I take raw data and turn it into an object with the originator function. I save that raw data object as a memento, and then I turn that memento into caretaker storage of saved. So that now stores this initial raw data all the way in the caretaker as a stored memento. This just creates a memento of the raw data object. And this here sets an object to the raw data in order for it to be output in the prompt. So this is the second set of data. Notice I changed the name to my last name, Walker. And this one we aren't going to save all the way to caretaker. So we are not using this as a backup. This is just changing our stored data. So our originator and data is set to Walker student 21. It is no longer Ben student 21. And we output that to show that the data has been changed. This here will load the data from the caretaker storage, which again takes it from caretaker storage back into a memento back into an object, and that object is then put out as raw data. I'm not sure if my recording software will record this command prompt window. I may need to change windows on it again, so let's see. It looks like it did not shift, but it may be recording, so just give me 1 second to check that out. This is the output from my code. The first line output is Ben, student 21. This was stored as a memento and then put all the way inside of our caretaker. The second line output was Walker, student 21. This was not stored as a memento but was output. And then our data was restored from data 2 to data 1. As we can see, it says Ben, student 21. So we went and we output data 1 and saved it, changed to data 2 and output that, and then went back to the original data of data 1 by taking the stored memento from the caretaker.